Hello everyone, welcome back. I hope you had a nice break. My name is Anna Pelker. I'm working for Deutsche Post DHL Group, and I will be your moderator for this session. This session is about data analytics and Internet of Things. Let's start with our first presenter. It is David Larson from Post North. He will be introduce us in robotic depalletizing. It's up to you, David.
Yes. Hello, everybody. My name is David. I have worked in different organizations, but always with logistics and technique. I've been in PostNord for 6 years now, and I work with strategic technology development. This is not so much about data analytics, but more about automation, but like in the last session, but I'll continue anyhow. And yes, I managed to send slides. PostNord, as most of you, face the challenge of both keeping costs low and at the same time manage growth. Means that we need to reduce the need for manual labor in the parcel sorting process, and we need to increase sorting capacity, and we need to build new terminals. And we need to plan and decide how the future terminals shall be built and what kind of machines we shall place in them. And it's likely that we make good decisions if we can first get practical knowledge of the feasibility and potential of future technologies. And one potentially interesting technology is vision guiding robotic arms that pick and place parcels. The idea is, of course, to replace human hands and eyes for doing the parcel sorting work, sometimes without changing the overall process at all. We have seen vision-guided parcel picking robots at fairs, in marketing materials and films on the internet, but so far PostNord has not found any product suitable for just our processes and parcel mixes. As we really would like to get practical experience of robot technology, we decided to take help and design a robotic cell ourselves to learn from that. The current processes and terminals are built for humans to work in them. And this particular technology, robotic arms, is designed to work like humans. Therefore, we have not tried to re-engineer any processes, but instead look for where robots has best potential to be at least the least inferior to a worker when the processes are unchanged. And in order of how many employees that work with different tasks, we have listed areas where we think the technology can have most potential. The biggest potential, we think, is in sorting big and small parcels into roller containers in the sorting for distribution process. Second biggest is to stow parcels in loose loaded trailers or unload parcels from the same trailers. And finally, we sometimes pick parcels coming stowed on pallets directly from customers and feed them into the sorting machines. These are these pallets, and we decided to start with them because it was judged technically easiest. The most important factor is that one can choose to handle only parcels that are suitable for the gripper and robot. The robot isn't surprised by what it encounters. And it is also so that the vision system does not need to decide the best gripping angle, and it doesn't need to pack the parcels tightly. All of them can be placed in the same spot. And we judged that to be able to compete with manual feeding of a sorting machine, a robot needed to be able to handle 600 parcels an hour and from 2 different pallet positions. The pallets our customers send us can be 2 meters high, and the stacking can be made both on regular and in layers. In the end, the number of vision cameras and their integration will influence the final cost of the cell quite a lot. And therefore we wanted a robotic cell designed so that only 1 camera was needed. The first thing we learned was that the cameras we tested could only produce pictures with robot guiding quality if the distance between the camera and the photographed parcel was between 0.5 meter and 1.5 meter from the camera. In the picture, that is the distance I have written quality beside. We of course expect there to be cameras that can focus over the whole distance, but they come at a much higher price and have therefore not been tested. So, as the pallets can be 2 meters high, none of the tested cameras will be able to guide the robot if mounted in fixed position above the pallet positions. We also learned that the cameras needed to be in a standstill when taking the photos. So the idea to somehow mount the cameras on the robotic arm would, even if it was possible, come with a drawback that the workpace of the robot would be lowered. To let the robotic cell work with as few interruptions as possible, the robot is placed in the center of a square. The pallet positions are on both sides of the robot. On the third side is the conveyor onto which the parcels shall be placed, and from the fourth side, the operator shall exchange empty pallets for loaded ones. Everything is placed inside a security cell, and light curtains shall protect the open side from where the pallets are replaced. The idea is that the operator is able to switch pallets in one position while the robot is emptying the pallets on the other position. And since we want cost-efficient cells with only one camera, the solution is to mount the camera on a linear unit so that it can be lowered as depalletization progresses. The linear unit is in turn mounted on a sledge that move it between the pallet places. In the sketch, the blue top of the frame is rails on which the sledge can move. One thing specific for depalletization is that the parcels are placed on other parcels that we do not know the height of. In the sketch, I have marked 3 distances. If the robotic arm shall place a parcel from the absolute correct height, the lower right measure, parcel's height, must be known. That could be calculated as the difference between the 2 other measures, conveyor distance and gripping distance. But our parcels are standing on other parcels that we do not know the height of, so we do not have enough information to do this calculation. And it is consequently difficult to know at what height from the placing surface the robot shall let go of the parcel. And this problem can be handled in several ways. One is to let the robot search for the correct drop height using a photo cell. Such solutions slow down the robot considerably. We were recommended not to exceed the speed of 10 centimeters per second when in search mode. Another alternative is to let the camera photograph the surface from where the parcels was picked. That is possible, but it would add a lot of complexity, and the tested software was not prepared for it. Our preferred solution is therefore that the robot, when placing the parcels, shall let go of all parcels from the same height, even if it means they fall 20 or 30 centimeters. Our tests have shown that the parcels are not damaged by this, nor do they bounce off the conveyor. And if you see films on similar solutions on the internet, you will find that more than us have chosen this way to do it. And now it's time to talk about where we are right now. Due to a quite sudden change in Sweden's authorities' views on manual handling of heavy parcels, PostNord have gotten a need to also investigate the handling of parcels up to 35 kilos, which is much heavier than originally specified. This will require changes, both in the size of the robot and the size of the cell, and also the steering of how the robot places the parcels. The cell must still be able to perform according to current specifications, but also to heavier parcels. it is not enough for the technique to save money compared to today's way of working with operators. It must also be better than all other technologies, like dippers and singulators, at least for its specified use. And we will therefore continue the work by redesigning the cell so it can handle both heavier parcels and the previously specified up to 15 kilogram ones. And I hope we can come back at another event with a report of this continued work. Thank you for listening.
Thank you very much, David, for your presentation. If you have any questions, please use Slido for that. Our next presenter is Martin Konrad from Deutsche Post DHL Group. He will give us some information about agile and data-driven parcel sorting. So it's up to you, Martin.
Thank you, Anna. Thank you. And welcome to my talk on agile and data-driven parcel sorting. So now coming from the more physical world, automation robots, to the process world and data and IT world. My name is Martin. I am the team lead IT, and I work for the German Post, Deutsche Post DHL. When I got to the DHL, we had 3 years ago, we had some issues with our optimizing of sorting capacity. We were starting to build 50K, so 500,000 parcels per hour sorting centers, and use the multi-vendor approach. So the different people and different suppliers involved in what we are building. And therefore, we found that a central control system is necessary in order to connect all these systems and to optimize routing through them. We also found that, in general, these smart material flow systems are vendor-specific, so you can't just buy them and integrate them. But we had to make someone build one for our solution. And we had this semi-customized solution by an IT giant, and we quickly found out that it was underperforming in adaptability, reliability, transparency, and throughput. So we were not that happy. And on top of that, we had a lot of internal resources bound by maintenance and operations instead of optimization of the sorting process. So we didn't even have enough time to think about what we can do better, because we were so involved in making this work what we had. So what we did is to go for it fully, and we tried to build a custom solution with an agile approach. So what our management did is risking that, trying to allow us to build this custom solution we called Polaris. And we had a team of internal and external developers set the task. The goal of the system was to control the routing and allow testing of new algorithms, and in the end, increase sorting system performance. You must imagine we have around 30 decision points where we have our 50,000 parcels per hour put through. So there's a lot of decisions to be made in a quick instance. So we can get every K that we have paid a lot of money for the system to be able to get all these Ks parcels sorted in the time that we need, because as we already heard, there's a lot of parcels coming in the system, in the network, and in Germany we have the same issues as Charles also described. So what we did is we used a Scrum-based approach, and we had a small team develop a minimum viable product, so something that can be used, even if it was not fully functional in every detail, that we could test early in production. And starting there, we had it constantly extended and heavily tested again and again. So adding every increment of functionality one place at a time. And what we always did is a close communication with our future customers, so we know that what we are building was made for the people that would use it. Having a quick look at what we built there, On the left-hand side is our interfaces, so the process control system that controlled where the parcel should go. Overall, we had the external services that could, like image recognition services that could be added to our Polaris infrastructure, and of course the sorting system, the PLCs that had to physically move the parcels to their target location. And we see these three pillars, this Polaris flow control that was built for optimizing the throughput, Polaris analytics to analyzing and reporting all the data that we have to make people find something out about this and make the system better in the end. And SCADA, supervisory control and data acquisition, to identify physical issues in the machines so we can send someone out to fix whatever is broken. Yeah, and we base this on a microservice architecture, so small services, small parts that do their job, only their job, and they communicate via message brokers. We built some decentral components close to the PLCs for time-critical decisions. We had a Docker container infrastructure for fast deployment and high availability. We didn't use any fancy infrastructure, but really standard servers with virtualization and open source software for database, Postgres, and Grafana as a reporting and data analytics tool that everybody could use, whoever wanted. Building that up in the beginning, we had pretty rough schedule. It went fast and stable, as I wrote. So we had around 8 months of development. In close collaboration with our suppliers, we had possibility to improve our data handling concept and the routing concept, build up with them together. Had only 10 days of initial system integration, and that was only possible because Polaris was able to control communication to all involved systems, and therefore we had the chance to have a deep analysis and really to see where the issues lay and fix them as fast as possible, so we could go on with this integration period. And from that point on until now, we had 22 months already of stable operations. The system is running and running, and we had just one really short outage in the beginning, which didn't even cause us to have some parcels left over. So pretty good result for this quick building. I mentioned, read 1 second. I mentioned data-driven in the beginning. So what do we understand from that? For us, it's important to control and to share the data. So what we did from the beginning on was combining and collecting all the data from the sorting systems. So from the sorter systems, from the identification system, the PLCs, put them all together and then made them accessible for all the experts. So for our team, for the neighboring teams, and also for our suppliers to draw conclusions from it and to improve whatever we have in sorting capacity. For the data that is responsible for the routing decisions, we decided to implement a direct data exchange, so not using any third-party middleware or databases. There's a direct connection to all the other systems, so we can control that better and have really the important data really quick there, so we can have informed decisions. Sending parcels, for example, not to regions where we have an outage or a blockage of the path, for example. So we don't lose any, we don't have any additional blockages there. We really want to go for the full capacity. And we also did simplification of interfaces and harmonization of identifiers between all the involved systems. So a parcel has the same identifier in every system, which makes it really easy to analyze over all the systems and find issues with this. Looking a little bit more on the process view, I think we had these, I would sum up these 5 pillars that I think made our challenging IT project work, beginning with an open mindset. I would say that kind of a form follows function. So we only do what works and don't build it because it's nice, but we build it because it works. And we always adapted the process and observed. So we made some changes to the Scrum framework, which is a well-known framework for agile and development, and saw what works and what doesn't work. Maybe sometimes see that there is a lot of reasoning behind this and some intelligent ideas, and finding out that changing it is maybe not a good idea, but always trying out and not only sticking to what is given there. More in the development view, this fail fast mentality was really important for me. Really starting with a minimum viable product, build something that works. And if it's not working, throw it away and try again. This kind of a rapid prototyping. Always talking to the people that can evaluate if it's good or not, and see errors as something that help us move forward. Not thinking about who did it wrong, but working on the problem and continuing. In the middle, this pillar of personal responsibility, like working as a team, having our courageous management allow us to work as a team, that they put a lot of trust into our team, and we tried to validate this trust to make them feel that they did it. That it was good that they challenged themselves and allowing us to do it. Also, by taking defects seriously, we always, whatever we found, we fixed it pretty fast. And also try to focus on what makes us successful. So that everyone does his part, and we're all in this together, winning as a team and also losing as a team. Not caring about who did what wrong, just trying to fix it as a team together. And then this experts culture, like starting, for example, with security by design, really trying from the beginning on to make it safe and secure what we're building. Not caring about pride, not thinking about, oh, this was not invented here, we can't use it, but really using whatever works and using good ideas from colleagues and suppliers, and really taking everything that we can and not being too picky about what, no, we didn't do that, we can't use it. But yeah, really working as a team, exchanging ideas and taking everyone's good ideas. And the last pillar for me, I call it joy fuels excellence. Starting with using current technologies to make the nerds happy, trying to have fun at work, because I think only if you have fun and enjoy what you're doing, you can be really, really good. Having kind of an end-to-end responsibility to see that you can have an impact. Every person in the team can have an impact, and we don't have to rely on someone else. It's us who can fix it and make it better. And also seeing that it makes something better, talking to the customers, to the users, and seeing that it makes their life easier. And yeah, that helped a lot. So let me conclude. I would ask everyone who can to invite excellence, like allowing the people to make them trust team with an agile approach, focusing on maintainability and low complexity, not making it too fancy, opening up your data stores, be courageous. You don't have to fear that someone takes your data and like someone internal takes your data and does something stupid with it. It's much more chances in that sharing this data, and talking to your customers, see what really counts for them and make it work. So that's what made our agile and data-driven approach in the end measurably reduce costs and increase throughput for our sorting centers. So thank you. Back to Anna.
Yeah, thank you, Martin, for your introduction to this topic. Yeah, if you have any question, please use Slido for the questions. Our next and last presenter of the session is Niklas Wüst from Swiss Post. He has prepared a video about agri-physical intelligence helps human beings. So let's start the video of Niklas.
Hi everyone. We are reaching the end of the day one. I hope you enjoy the previous presentations as much as I did, and that you have still a bit of energy and concentration for this one. I'm very happy to present a project that has been successfully implemented in production. Everybody have heard about artificial intelligence, but few are actually using it. You will find my contact details on the presentation that will be available for everyone. Feel free to contact me in case of interest or question. Starting a new project, you always face some challenges. In this case, I have highlighted 4 main ones. First of all, trying technical stuff on deep learning technology. Implement a key process on daily activities, time saving or data entry, process automation. Finally, sharing knowledges with colleagues for future projects. The solution. Connex camera was selected mainly for its capability of reading optical character recognition. Data to be automated is a 15 digits number as well as the address highlighted in green on this picture. You can see here the end model. The main features I would like to share are capacity to read various characters and fonts as well as different spacing. The inclination has little impact, which facilitates fast processing. Please note that the tool was challenged by using scenarios until we arrived at the result we were looking for. The development process can be divided into 3 steps. First, reading is triggered by a sensor detecting the presence of an invoice. Image is analyzed. If a match with a pattern is found, character string is sent. Character string is received and dedicated application and automatically validated. All characters are analyzed and a quality scale has been set for us at 92%. We will see on that as soon as the system has been provided with enough data, the results are very satisfactory. Now, better than word and figures, here's a video we have made to explain well what was our target and how we have reached it.
Au niveau justement de la saisie, quand elle les recevait, on devait tout faire à la main quasiment. Il fallait d'abord les trier par raison de non-distribution. Donc on avait par exemple les étiquettes qui sont différentes couleurs, qui ont toutes une signification. Quand il y a beaucoup de quantité des fois, c'est vrai qu'à la longue, ça fatigue, ça use les yeux et on ne sait pas peut-être si on tape toujours le bon numéro.
Et la caméra arrive en fait à lire nettement plus rapidement que le collaborateur et surtout un grand confort de concentration qui n'est plus obligé d'être fait. On n'a que de la manutention de mouvement pour mettre l'objet en fait sous la caméra. On n'a pas cet effort de concentration pour décoder le chiffre, décrypter le chiffre.
Alors on a moins de saisie justement, on se fatigue un peu moins, mais la caméra elle au moins saisit juste. On va faire confiance à cette caméra qui elle fait le travail quasi parfait, à la perfection.
On fait l'acquisition d'images, des photos, en fait, ces envois, avec tous les défauts qu'on peut lui trouver, donc barrés, de l'encre qui a bavé, des écritures qui sont de très mauvaise qualité. Et il y a un processus neuronal, en fait, c'est l'intelligence artificielle, un processus neuronal qui va décrypter tous ces chiffres-là et va nous faire une proposition. Il va nous proposer, par exemple, un 6 au lieu d'un 5, et on va lui dire non, ça c'est un 5. Donc elle va retenir cette information-là et tout ce qui est similaire ensuite à ce qu'on lui a appris, elle va retenir. Et on voit que c'est quand même beaucoup plus agréable pour tout le monde d'avoir ce genre de modernité, de saisie, de confort de saisie, plutôt d'avoir des choses, on ne va pas dire archaïques, parce que la saisie existera toujours, mais on a pu moderniser une tâche.
Contrairement à certaines idées reçues, la Poste est extrêmement innovante. Et dans ce cadre-là, c'est très intéressant de voir que ces 2 collègues, effectivement, un technicien, quelqu'un de la production, qui ont pris à bras-le-corps une problématique.
C'est vraiment une discussion entre 2 collègues, un qui a un besoin, puis l'autre qui a des compétences. En réfléchissant comme ça, on s'est dit, tiens, est-ce qu'on peut faire quelque chose? Puis c'était une collaboration nette et franche. Puis d'un coup, c'est venu un petit projet on a vu, ça intéressait beaucoup de monde, on a présenté ça à nos cadres supérieurs, on a dit voilà, il y a ça et ça qu'on peut faire. Ah, faites une petite démo, voir ce que ça vaut. Puis tout le monde était bluffé par la performance des deux caméras, que ce soit pour le type OCR ou le type code à barre.
On parle d'intelligence artificielle, on en parle souvent, on voit beaucoup de reportages dessus, mais finalement, c'est encore pas très déployé dans le monde industriel sur des applications concrètes. Et c'est ça qui me réjouit énormément dans ce cas présent, dans ce cas précis, c'est qu'on a une application absolument concrète avec d'une part un retour sur investissement vraiment important qui se fait en moins de 2 ans. Et puis en parallèle de cela, on a des collaborateurs qui aujourd'hui ont une ergonomie qui est largement améliorée. I hope you enjoyed the video. As a result, on a technical point of view, our main goal was of course to lower our staff labor and have a system that will be able to reach as much as human eye. This has been largely successful. The return of investment has been reached in less than 2 years and met of course our expectation. We have succeeded in greatly reducing manual work. On the graph, you can see that once the tool was fitted with enough data, we have seen a huge drop of manual entry, and within 3 months, we have already met our first target. Finally, if you have to keep something, artificial intelligence has become something real for us, and we can clearly see the benefits. First, improved working place, technical performance that meets our expectation. What the human eye sees, the camera sees too. It's the main thing. And finally, wide range of a new perspective in the development of Swiss Post. I hope that these few words on artificial intelligence interested you. Thanks for your attention.